Hello, ladies and gentlemen. Today we're going to be talking about synthetic division. This is a very specific process that we can only use for certain kinds of division with polynomials, but we're going to find that it actually can be very, very helpful for some of the things that we're going to be doing in the future with these polynomials, okay? So basically, when are we going to use synthetic division? The whole point of it is a great way to figure out if a binomial is a factor of your polynomial. Specifically, if you want to think of it easier, if you look at a number and you say, I want to know if this is the root, one of the roots of this polynomial, this is a way to do that, okay? But based off that fact, this only can be done if we are dividing by a binomial, specifically a binomial where our x does not have a coefficient with it, right? It has to be in the form of either x plus a number or x minus a number, something like that, okay? Now, on these note sheet, I have written out all the steps that you need to know in order to do synthetic division, okay? But I'm actually going to just go ahead and show you the process on my own. I have attached in Schoology the notes here, so you can go and look at those notes if you want to see this list by list, these steps that I'm going to kind of talk you through here on our own, okay? But let's go ahead, let's look at this example right here. We're going to do 2x squared plus 5x plus 3, and we're going to divide it by x plus 1. So here's how we're going to do synthetic division. We're going to start by drawing almost like a long division bar, okay? We're just going to write a big long division bar, okay? We're going to take all the coefficients of this right here, and we're going to write them across the top. 2, 5, and 3. Okay? We're then going to write a number down here based off our what we're dividing into, what our divisor is here. Now, we're going to write down the number -1. Now, you might be wondering, Mr. Guy, I see a +1 there. Why are you writing a -1 down here? Basically, what you're going to write down is kind of like, you know, when we solve for roots and we have a factor and we set equal to 0 and we solve, okay? That's kind of the idea of what you're writing the number is down there. Basically, the opposite of the number you see here. If I set this equal to 0 and solve, that would be the root that would correlate with it, okay? And that's the number we're going to write down here, okay? The next thing you're going to do is you're going to take this first number and you're just going to write it down here. That's just going to stay no problem. We're then going to multiply these two numbers. We're going to say, all right, -1 times 2, that's going to give me -2. I'm going to write that up here. And then I'm going to carry this down and I'm going to do whatever the addition, add these two numbers together, okay? So 5 plus -2, that gives me 3. I write that here. I then go ahead and multiply this by -1. Okay, I'm going to get -3. And then I add these two numbers together right here, and I'm going to get 0. Whenever you're done doing that, so however long it goes, you're going to keep doing it. You'll see we'll do a couple examples. Whatever your last number is, you're going to put into a little box. That number right there is going to be your remainder. The other numbers are going to be your quotient. They're all the coefficients for your quotient. And you can kind of write them. You also want to write them in reverse order because this one's going to be 3. This one's going to be 2x. You kind of go along and you just kind of add on a degree as we go, okay? So 2x plus 3. That's going to be our quotient. That's going to be our answer, okay? Now, when you do synthetic division, if you get a remainder, like a remainder of 1 or 2 or whatever it is, that means that this was not a factor. If you don't get a remainder, like we don't have a remainder here, that means that x plus 1 was a factor of this, and I actually can write them out. X plus 1 times 2x plus 3 is another way I could rewrite the 2x squared plus 5x plus 3. Basically, I factored it into these two factors, okay? Let's look at another example. Okay, again, this is very much process heavy. You just kind of do the process, and you'll get the answer here. So we're going to write these coefficients across the top. Our coefficients for this one are 1, -1, -1, 1. Okay, we see x minus 1 down here, so 1 is the number we're going to write here. That's the number, if I plugged it in, I would get 0, right? Kind of the root that goes along with this factor. I'll start by bringing down that first number, whatever it is, you just bring it right on down. Then we're going to multiply. 1 times 1 gives me 1. I add these together, I get 0. 1 times 0 gives me 0. I add these together, I get -1. 1 times -1 gives me -1. Add these together, I get 0. Whatever your last number is, that's your remainder. Lucky me, I have a remainder of 0. Then I kind of go backwards. This one's going to be my constant term. This would be my x term, so I don't really need to write it because it's 0. This would be my x squared term. x squared minus 1 is what my quotient's going to be. That's going to be what happens when I divide these two together. Which means I can now rewrite this polynomial as x squared minus 1 times x minus 1. Okay? Let's go ahead. Let's go a little bit further. Let's do the same thing here. Let's do another synthetic division problem, okay? I'm going to take the coefficients. I'm going to write them across the top. So I'm going to write 2, -3, -3, and 2. My root that goes along with this factor is going to be 2. I'm going to bring down this first number no matter what. Just bring it down. 2 times 2 gives me 4. -3 plus 4 is 1. 2 times 1 gives me 2. -3 plus 2 gives me -1. 2 times -2 is -2. Add them together, I get 0. Okay? Again, I'm going to rewrite out this over here. Got to kind of go backwards. That's going to be my constant term. That's going to be my x term. This is going to be the coefficient for my x squared term. Okay, so if I wanted to rewrite this with the factor, it's going to be x minus 2 times 2x squared plus x minus 1. Okay, let's look at this one. So this one's going to be a little bit different, a little bit weirder than the other ones. Let me erase some of my work here so I can see. Okay, the difference with this one is that we are actually missing an x term, right? So when I go ahead and I write my coefficients up here, I need to write 2, -1, and then I need to put a 0 in as a placeholder. Okay, 0 goes in as a placeholder, and then 3. Okay, 3 is going to be my factor that goes along with this. So I'm going to be dividing in. I'll bring down this 2. 3 times 2 gives me 6. -1 plus 6 is 5. You'll notice you'll kind of get into like a trance or like a just kind of get into a motion of doing these, right? This and this and this and this, because it's very procedural. I bring down the first number, I multiply, write that number, I add. I multiply, write that number, I add. I multiply, write that number, I add. You just kind of keep going, right? You just kind of keep going through as you go, all right? 3 times 5 is going to be 15. Add those together, I get 15. 3 times 15 is going to be 45. And then add those together, I'm going to get 48 as my remainder. Okay? Now, that means that this does not go in evenly. Okay, this is one that it would not, x minus 3 would not be a factor of that. So I go ahead and I write this out as 2x, or I write it out as 15 is my constant term, 5x, and then we have 2x squared. So that would be my answer, and then I have a remainder of 48. Okay? Last one here that we're going to look at, okay, same sort of deal. Erase all these. Here, get out of my way. Okay, same sort of deal. We're going to do synthetic division. We'll write the same sort of thing out. Again, this one's also missing some stuff. So we have a 1, and we're missing x cubed, so I'll put a 0 there. We have a 1 for x squared. I'm missing an x, put a 0 there. And then we have a 2, and I'm going to put a 2 down here, because again, that's what's going to get me to 0 there, right? Bring down the 1. 2 times 1 is 2. Add those together, I get 2. 2 times 2 is 4. Add those together, I get 5. 5 times 2 is 10. Add those together, I get 10. 2 times 10 is 20. Add those together, I get 22. Again, this one also does not go in evenly. When I go to write out my answer, 10, 5x, 2x squared, x cubed, with some plus signs in the middle, and then we have a remainder of 22. Remember, I also can go ahead and write my remainder as plus 22 over x minus 2. Okay, I can also write it like that. I also could write it using the division algorithm that we talked about with long division as well if I wanted to. Okay, so that's how we do synthetic division. Again, it's very procedural. You bring down that first number, multiply, add, multiply, add, multiply, add, multiply, add. You just do that over and over again. And remember, the big thing to keep in mind is synthetic division. We can only do it if we're dividing by a binomial that is in the form x plus a number or x minus a number, whatever it is. Okay, it has to be in that form So there can't be a coefficient with x. It has to be a binomial. Then we can go ahead and use our synthetic division. All right? Thank you all for watching.